So now let's take a look at some of the control signals we saw. So we saw those two muxes, and here's the first one. This is the ALU source, and we're going to look at what it is. So here's an instruction. We're looking at add I, add immediate. What value are we going to use for ALU source for the add immediate instruction? Well, add immediate takes one operand from the sign extended immediate field. So the mux is going to take the signal from input 1. So we have one input from the register file, and one input is going to come from the sign extended immediate. Here's another question for the instruction add. So this isn't an immediate instruction, this is an R instruction, so just add. What is the value of this mux going to be for that? Well, it's going to be 1, because the add instruction takes two operands in the register file. So the first one comes from the register file here, and the second one is going to go through the mux directly from the register file. So this should give you a feeling for how we're going to get these control signals, and you can look at the instruction type and figure out which control signals to use. So now let's talk about building the branch unit. So we talked about how we hook up the register file, the ALU, and the memory. Let's talk about how we handle branches. So first of all, what does it do? Remember the default. The default is just the next program counter equals the current program counter plus 4. And to do that, we need an adder that'll add 4 to it. So we've got our program counter, I'm going to put it into our adder is going to add 4, and then we're going to feed that back as the next program counter value. But that's not what we do when we have a conditional branch. Conditional branches are more complicated. So we're going to do PC plus 4, and then we're going to add in this sign extended immediate, but we shift it over a bit. Remember, we shifted over by 2 because we can't have unword aligned addresses. And we only do this if we take the branch. So if we don't take the branch, we do the regular PC plus 4. If we do take the branch, we do this. So we need to look down at our design here and see how do we build this. So the first thing we're going to do is take the instruction, and from the instruction we're going to get that immediate value. Now we need to sign extend the immediate value so that we can use it to calculate the branch address. We can then take this sign extend immediate value, we need to shift it left by 2, and then we're going to add it. And what are we going to add it to? Well, we're going to add it to what we had before. We're going to add it to PC plus 4. So now we've got PC plus 4 plus the shifted sign extended immediate result. Now we need to use this if we do a branch. So we take that output and we put it into a mux. And this mux is going to decide, do we take the branch address or just the next instruction address? And if we do take the branch address, then we're going to use this input to the mux, and now we're going to have our next PC be the branch address instead. So here's a question. Why do we have this second adder for doing branches? Is this because we need fewer bits than the main ALU? Is it because the ALU is needed for testing equality? Or is it because we need a special adder for immediate values? Well, the answer here is the ALU is needed for testing equality. So remember, when we do a branch, we use the ALU to do subtraction. If the subtraction is 0, that means the two values are equal, and then we can use that to decide if we should take the branch. But we also need to use another adder to compute the branch address. So we need two adders, one to compute the branch address, one to compute whether or not we should take the branch. So let's take a look at that PC source signal that we were looking at, the one that decides whether we use the branch address or the next instruction address. When do we select the ALU result instead of PC plus 4? That is, when do we use this mux to select the branch destination instead of the next instruction? Do we do this when we have a branch equal instruction and ALU 0 is true? Do we do it whenever we have a branch equal or not equal instruction? Or do we do it whenever the ALU 0 is true? So we do this only when we have a branch instruction and ALU 0 is true. So if we have branch equal, that means we branch if they're equal. And so if ALU 0 is true, that means they are equal. And in that case, we're going to select the branch address. If we don't have a branch instruction, or they're not equal, we're going to do just the regular PC plus 4. And remember, this is the opposite for branch not equal. So for branch not equal, we're going to do the branch if 0 is not true. That is, if the values are not the same.